Script?
Got it.
Guest bio?
Check. You have the questions?
Finished last night. Let's test the intro.
How do you bring innovative technology to the public?
What kind of organization do you need to make the technology actually work?
Hi, this is Tamara Carlton.
And David Allen.
For How We Manage Stuff.
Today, we'll look at how you build an innovative organization.
And we'll be joined by special guest, Steve Crocker, the board chair from the Internet Corporation for Assigned Names and Numbers.
And we're just a little long. Rohit, can you fix that?
Rohit's not in the control room. He's still at the Washington Navy Yard.
All right. Still doing community service for getting past their cybersecurity. Anna, are you in the control?
No, it's me.
Vinny, so when does our CTO have to do time in the control room?
It starts with our IT guy doing community service for hacking a pass into the government facility.
Rohit is not out yet?
No, he's still got some splaining to do.
And what about Anna and her crowdsourcers?
Young professionals and technology networking luncheon at the National Press Club.
That's right. I remember it. I thought it'd be good exposure for her.
Maybe. She spent 30 minutes choosing the right shoes for the event.
Sure. Vinny, he's going to be fine with the software?
I'm right here, you know.
He's fine. I briefed him on all the oddities of the system. You know, we really should upgrade this stuff to a more professional system.
Ah, but you know the problem.
Yeah, the professional system is sometime more flaky than what we've got.
And the CEO of the major competition.
Horrible man, horrible company.
And we don't know how they make their software.
Isn't it by indentured servants in a sweatshop located in a dismally exploited country?
Oh, there are rumors.
Oh, anyway, if anything goes wrong, he can text me.
Where are you going to be?
Getting a pedicure at Eastern Market. Feet massaged, toes painted. In 90 minutes, I'll be a new woman.
But text you?
It is the original Power Nail Salon. Last week, the woman next to me was coordinating the release of Supreme Court decisions. And the guy across the way?
Guy?
First breach of the defenses. We're trying to keep the male gender ignorant of the deep pleasure of this experience. Anyway, he was working on a trade agreement and kept texting Geneva.
Go. Are you ready, Vinny?
I am, and I'm still here.
Do you want to be part of the discussions today?
Well, there are a couple of things that interest me.
Such as?
Well, first is to hear what's happening with the Internet and ICANN. ICANN is the one institution that really is central to the Internet. Internet Corporation on Assigned Names and Numbers. They put the dot in .com.
And in .edu, .org, .net, and all the other dot stuff.
If it goes down, well, you know, there goes the game. People talk about making it more responsive, more agile. I don't want it responsive. I want it stable, real stable.
Yeah, he's going to talk about this a bit.
And then his stuff on error-free software, that could be good for us.
Really?
Oh, yeah. Put us right in the center. The big play. When we got error-free hardware in the 80s, we did it through theory, through tools, and through organization.
Well, then...
Have the How We Manage Stuff division on error-free and agile software. It will be so us.
So do you mean this is a repeat of your first company? It's Side Pocket 2.
Tell me you can't see the corner office in San Francisco high-rise and the entrepreneurs of the world beating a path to your door.
Maybe we shouldn't get ahead of ourselves.
I mean, look at those notes on our software that Rohit left for us. Half of them, well, a lot of them deal with errors. High band pass filter doesn't work. It's a low band pass filter. Use auto capture version 20 with control panel version 15 because control panel 20 hangs the system. I mean, this is just garbage.
What can we say?
Do not click the output monitor button. I wonder why not.
No, Vinny.
Because it's actually an input. Ready to go. David, camera. Are you there? Camera. They're gone. What do I do? Nothing. Let's just reboot. David, camera, you there?
Yes, we are.
I think it's time to move to our guest. Can we start?
Sure.
We'd like to welcome Steve Crocker.
Thank you.
Steve, why don't you tell us a bit about yourself?
Hi there. My name is Steve Crocker. I'm chairman of the board of ICANN, the Internet Corporation for Assigned Names and Numbers, which oversees the domain name system for the Internet.
Perhaps we should start by telling our listeners just a little bit about the Internet domain name system.
The domain name system is part of the machinery that makes the network work. Things like www.icann.org is a domain name. If you type that into your browser and then you want to be connected to that site, that string has to be translated into an Internet protocol address. And that translation is done through a series of queries to domain name servers. So to get to www.icann.org, the initial query might go to a root server, which would say, I don't know the full answer to your question, but I can tell you where the servers for .org are. And the .org server will say, I can't tell you the full answer, but the ICANN.org servers are over here. And at that point, your browser can make a connection to the website.
And ICANN runs the domain name system, or at least the top part of it. And does it also create the software for it?
The software that actually does the work comes from a handful of organizations, almost all of which provide the software for free.
And would our listeners be familiar with this software?
The one that got ahead of the game was called Bind. It's now provided by a nonprofit in California called the Internet Systems Consortium.
And the system got you thinking about the reliability of software.
About 5 years ago, I became aware of a bug in the current versions of Bind. The bug was discovered in an accidental way, sort of like the discovery of penicillin, in a laboratory in England, a company called Nominet, which runs .uk.
And how did they find this bug?
I noticed something that looked peculiar. In tracking down the peculiarity, they discovered that in recently released versions of Bind, a single packet, not one that would be naturally occurring, but one that could be constructed, would cause the system to crash.
It made one server vulnerable. But did it put the entire internet at risk?
It does not take a lot of machine power to test every single machine on the network. And so in a relatively few minutes, with no more power than a laptop computer, you can send this particular malformed packet out into the world of each and every one of these DNS systems. And now they will all crash.
Okay, so you found a bug that made the network vulnerable. What did you do?
Well, I called two people. I called the Assistant Secretary of Commerce, whose agency oversees ICANN, and I called the cybersecurity czar in the White House. I was on good terms with both of them, and we had a brief, factual, straightforward conversation, and they asked a couple questions, checked their people were all doing the right thing.
And how was the bug fixed?
The straightforward and ordinary repair processes took place. Key people were informed. Patches were put together quickly. The sun rose the next morning and nothing bad happened.
So this was the end of the problem?
Except for one small thing. The question that went through my mind is, why is it the case, after all this time, with all these huge advances, why is it that software that has elementary bugs of that type leaves the programmer's desk? Why is it that that's what the state of the art is?
Good question. Why do we still have buggy software?
I think the answer is multifaceted. We could certainly look at the technology question. Is it possible to formalize what the criteria is for not having that class of bugs? And the answer is not quite yet, but I think it's possible that we could do better than we have.
Okay, and what else do we need to consider? How should our listeners approach this kind of a subject?
The other thing is a social issue. We've been living with buggy software for so long that it's now viewed as a fact of life. I assert that every non-technical person and a vast majority of technical people simply believe that bugs happen. I think that that is wrong and is fixable.
But all manufactured goods have problems. You can find bugs in anything.
Back to computing hardware, it is not an acceptable thing to have a small bug show up like that. Intel had a small problem in which the arithmetic was not quite right. And the reaction from the business community was overwhelming. Intel first resisted and said, it's not a big deal and doesn't affect most things. But it cost them a couple $1 billion to do a recall. We have not yet gotten to that point with respect to software.
So how far is software behind hardware? Are we decades behind?
I have to admit, we've shifted some over the time. That we don't have the blue screen of death anymore. Microsoft put in a lot of energy and using some high-tech methods of preventing certain kinds of bugs. And the iPhones and the Androids don't break too often. So we're somewhere along the way of increasing expectations and demanding more, but not where I think we ought to be.
So what do we need to do?
It's been suggested that we have a Manhattan Project type plan I think it's got the following parts. One is a serious big push on the raw technology of proof techniques and packaging that up in a way that ordinary users can.
When you say packaging it up, exactly what do you mean?
I think there's room to develop an infrastructure for knowing what's inside the packet.
And something that describes the quality of the software.
Imagine that there could be attributes associated with the software that say, it was tested this way, here's what we think about the quality, et cetera, and that there was some rough standards for what those notes mean and that they could be put together and conveyed along with a shipping label.
And is there anything more?
At the other end of the spectrum is creating an expectation that software that is free of these sort of basic bugs is to be expected rather than the opposite. If it has these kind of basic bugs, then somebody screwed up and that's not okay.
I hear three things. Research on the techniques that prove software quality, a quality provenance label, sort of like the nutrition labels that we have on food. And finally, we need to change the attitudes and expectations of the public, and especially the direct consumers of software.
Taken all together, those things, I think, would have a first-order impact.
Thank you for coming and talking with us.
Thank you, David and Tamara.
It was good having you here, Steve. Perhaps we can have you back in the fall to talk about how we get to that world of error-free software.
You can take us out, Vinny.
Sure.
Vinny, are you there? What happened?
Let me call Evelyn.
I gotta take this. Hey, Tamara.
Evelyn?
That's what it should say on your phone. What happened?
Vinny.
Found the bugs in the software and has vanished from the face of the earth.
Yeah.
You know, I'm in a happy place right now. My feet are soaking. I'm surrounded by 3 very bright congressional aides who are not essential to the running of the government, including one with a Y chromosome.
Interesting.
Probably not, but he is a bit of a hunk. I'll reset the podcast from here.
Thanks.
Okay, bye.
David, Tamara, Tamara.
Vinny, good. You're back.
I have no idea what happened.
Software bug.
I mean, I was in this dark blue sky and there was a light.
Take us out, Vinny. One more time.
And so we take our first step towards the world of error-free software.
This is David Allen Grier.
And Tamara Carlton.
For How We Manage Stuff. Take care.
Someone has to make sure that things are done properly, even if you have to phone it in. Subscribe to How We Manage Stuff through iTunes or Google Play or our website, http://howwemanagestuff.com, or wherever fine podcasts are sold. This is episode 16355 and is copyright 2016 by Jaggy LLC, all rights reserved.